So what they want us to do is resolve this into two components x and y. Now what I'll suggest is just try to see this these four as force vectors. Chris, is it making sense?
Yes, sir.
So let us assume that these are newtons. These are newtons. These are newtons. And what we want is that these are the four forces which are acting on this particle which is at P. Is it making sense, Chris?
Yes, sir.
Let us assume that we have four forces A, B, C, D which are acting on a particle which is at the origin. Yeah. Now, if I want to see the net effect of these four forces on this particle P, then what I do is I resolve, to make things easier, I resolve the vectors in their x and y components. So for example, A in x and y component would be 15, the x component would be 15 cos 60 and 15 sin 60. Is it fine, Chris?
Yes, sir.
So I can calculate this. Of course, I can calculate this and find the answer. But right now what I am doing is I am just writing this as 15 cos 60 and 15 sin 60. Chris, is it okay? Chris,
Yes,
is it?
sir.
Yeah. See, if you closely look at B, B is already in the x direction. So its component in y direction would be 0. Is it making sense?
Yes, sir.
So in x, its magnitude is wholly solely in the x direction. It has no component in the y direction. So therefore the component of this 10 Newton force in the y direction would be 0. Are we clear?
Yes, sir. Yes.
Now let us look at the C force. The C force is wholly solely in the y direction. It is in the negative direction. So this will be minus 25 and it has no component in the x direction. So this would be 0. Is it making sense?
Yes.
These are slightly difficult questions than which will come to your exam. So don't worry. Now when we do your exam questions, they will seem very easy. So don't worry. Now when we look at the D force, the D force is in the negative direction. The x component, this x component is 50 cos 28 degree, but it is in negative direction of x-axis. That is why I am saying that the component would be minus cos 28 degree. Chris, is it making sense?
Yes, sir.
Similarly, if you look at the x component of this D, it would be in the negative direction and it will be sine 28. Chris, are we clear?
Yes, sir. Yes.
Yeah. Now the magic of forces, the magic of forces is that once we have resolved the forces into their individual components, then what I can do, Chris, and that is why this topic is important, is what I can do is I can handle these independently. I can handle these independently. I can add or subtract these independently, and I can add or subtract these independently. Have you understood what I have said?
Yes, sir.
So if these were the four forces, if A, B, C, D, now let us look at the question again. Let us look at the question again. If I had four forces A, B, C, D, which were acting on a particle P, like what is shown in the figure, then if I wanted to calculate the net force, what I would have done is, we will do your exam question also. After this, we'll do your exam question.
Yes, sir.
And now your exam question will seem very easy. So if I want a net force, the net effect of A plus B plus C plus D, what I can do is I can resolve A into X and Y component, I can resolve B into X and Y component, I can resolve C into X and Y component, I can resolve D into X and Y component, then I'll handle these X at one side and I'll handle the Y on the other side. Is it making sense, Chris?
Yes, sir. Yes.
So now I'll have to calculate the value of 15 cos 60, 15 sin 60, 50 cos 28, minus 50 sin 28. Can you tell me the values?
Yes. So
I'm sorry.
can you repeat the question?
Yeah. Can you find the values of 15 cos 60, 15 sin 60, 50 cos 28 and 50 sin 28? So see, this is what I've done. This 15 cos 60 degree can be written as 7.5. This 15 sin 60 degree is 13. So my force A has positive components. When I look at my force B, of course it has one component positive, other is 0, and the C force has one component 0, the other is negative. Now my D force has both the components negative. So one is minus 44.14, the other is minus 23.15. And this is what I was trying to tell you, that once I have resolved the four vectors in their respective x and y components, what I can do is I can independently handle my x component and I can independently handle my y component. So the net of x would be equal to minus 36. I have rounded this off to minus 37. My net of y is minus 85.14. I have rounded this off to minus 85, and this is this is the final resultant force vector of these four vectors. This is a resultant vector of the four forces which were acting on point P. One is minus 37 Newton in the left direction, this is the x component, and minus 85 which is acting in the negative y axis. And again, like we had discussed it before, if I want to find the component, the magnitude of this force, it will be given by Pythagoras theorem, 37 square plus 85 square is equal to 92.7 Newton. And if I want this component, if I want this theta, the angle theta would be tan inverse of the y component upon the x component, and my final answer would be 66.5 degree. Chris, is it making some sense?
Yes.
So it's a bit difficult. Now we'll do a easy question from your exam. Don't worry. But even if you have understood 50% of this question, now when we do your exam question, it will be very simple. Yeah. Should I show you your exam question?
Yes, sir.
Yeah. One second.